Can anyone? Hello?
Yeah, we can hear you.
Oh, okay, perfect. So tell me when we can start.
Yeah, we shall start
We want
in
to wait
a few
a little
minutes,
bit.
probably at 7:05 when a few more people join.
Okay.
So sorry. Before start, maybe Mr. Stagni.
Yeah, don't worry.
I'm the head coach here. My name is Long. So welcome for your volunteering to give us this.
It's a pleasure.
Forum. Okay, thank you. So yeah, I think that you think we can start now or wait?
Oh, 1 minute. There's a few people in the waiting room. How do I disable the waiting room?
You just like admit all.
Oh, okay. Okay, it's about 7:05 now, so I guess we'll start now. So good evening, everyone. My name is Dev Gavande, and welcome to First Tech Challenge Team's 18227 Area 52's 7th STEM Forum, covering new perspectives and challenges for the software industry. And we are joined by our guest speaker, Alessandro Stagni. So Alessandro Stagni has a master's degree in quantum electronics, and during the last 30 years, he has worked in 4 different fields in 3 different countries, and he's currently working in a premier consulting company as an associate director for the Low-Code, No-Code Center of Excellence for the North American market. And so I'm honored to introduce Alessandro Stagni as the keynote speaker for today's STEM Forum.
Okay, thank you. Thank you for the nice introduction. First of all, congratulations for the recent victory in the contest. I'd love to be able to see one of your battles, but let's start very quickly. So I'm doing also an experiment today. It's the first time I'm doing some kind of presentation using the contribution of OpenAI. I don't know how much of you are familiar, probably already familiar with ChatGPT. I'm not able to collect a poll, but I guess you know what it is about. So let's start very quickly. A couple of disclaimers, just if you are going to print or who is going to look at this few slides. These are my own opinion, and doesn't necessarily reflect. They don't necessarily reflect the opinion of the company I'm working for. The second one, just another disclaimer. I have a personal interest in a couple of products. One is Mendix low code, and the other one is the Amazon Web Service, my company's partner too. So I'm going to talk about this, but we will also try to understand what is in the market which are the alternatives. So the introduction was already done, so I can skip this slide. Just this is the university I went to, and I think that you are very young, and a lot of you, or almost all of you, will attend college. It's going to be tough, but I can say that after all these years, my best years were spent there. So try to enjoy that period. Is incredible. So how old am I, and how much experience I have? This is my first purchase of a book when I start to talk and to work on internet. So there weren't a search engine at the time. So we were using Yellow Pages. Perhaps a lot of you don't know what the Yellow Pages are. This is a big book with a lot of IP addresses, and you had to search alphabetical order some site that could be of your interest. So I saw almost all the history, the evolution of internet and distributed systems. Yeah, the important things here is understanding that the best part of this job is never the same. Each year, each month, there is something new to learn, and what seems to be at the cutting edge in a certain period, like, oh wow, to be able to use a modem at 300 baud or 900 to connect to the internet and search some site was incredible, even though you had to wait minutes to load a page. So what is happening is that this is the history or a never-ending automation. We can go through the history of automation, and I think that even though ChatGPT believes that the early automation started with the 18th century, everything we did as a species was trying to automate something or using a tool. The strange thing that happened now is that we are starting to automate the automation. So think about why computers and software was invented. I'd love to have answer from you, but I understand that it's difficult in a video call. So I'll give you what I think is the answer is, yes, to automate mathematics and calculation. And after that, and why to do that? To improve and automate the production of other tools and other machines, to arrive to write software to instruct robots on how to interact with the world. And now we are in the phase in which we are making automatic the production of software that make other stuff automatized. So it's interesting evolution, and this we will talk more about that. If you are curious about the images, these are images generated by OpenAI. I just gave them the theme of the slide and the suggestion of which kind of famous painter style. So you can try to guess who should be the author of this painting. Some of them is very difficult, but some of it's going to be easy. So why this introduction? So let's start to focus on software and software engineering. These are definitions from Wikipedia. So software engineering is a systemic engineering approach to software development. So a lot of rules, a lot of studies, a lot of optimization, but at the end is creating software and application and software for application. So what is software? Software is a computer program. What is a computer program? This is starting to be interesting. A computer program is a human readable form called source code. human readable is interesting because you can program a machine using directly hexadecimal numbers, but the common understanding is something that is like text that can be human readable. Really, if you ever saw the movie The Matrix, you can see these guys that can extract information from following characters and ideograms. The real problem is that a modern application code is counted in million lines. Sorry. Million lines of what you see here on the left. It's very difficult to understand what is there. And it requires, I knew very few developers that are able to grasp immediately what a snippet of code is doing without starting to not only read, because you can't read and understanding, you have to extract the logic from the text, and the code is becoming there were a lot of effort on trying to make it more human readable, but from my point of view, this is my personal view, human readability in terms of text is not the right approach, and this is not surprising. We will see what it means, what implies a no-code or low-code platform is fundamentally a visual approach to logic and to software development. You probably don't know these ladies. She has an incredible history. I recommend you to check on YouTube or around the story of his career. And he recently published a book that, if you have the time to read, is an incredible insight on how mind works and how visual-oriented people can, which kind of thought model visual-oriented people has. And taking account that if you're interested in engineering, you are probably a visual thinker. So when you start to grasp what a robot have to do, also when you start to visualize and define the code, define the logic, you are reasoning by image. And the interesting thing is that if you ask to ChatGPT what is low code or no code, just focus on the core text. Faster for people to build the deploy application. It's true. Is much faster. We will see also the limitation. But the fundamental part of all the no-code, the low-code platform, that they use visual models. They are not using code or trying to avoid as much as possible to define logic in terms of code. So there is something that works at a more deep intuitive level in dealing with the images and the visual constructs. In fact, at the end is like all these low-code platforms are, almost all of them are a way to develop assembling visual blocks. So I'd ask to raise the hand whoever in the team has played with Lego. And I expected that some of you did, and I still enjoy. I still enjoy. I'm going. I still play with Lego at my age. And after we have the more, to say, business-oriented parts, we will see what this means in a brief. But just to give you a visual hint of what you do when you open low-code platform. This is Mendix. We will talk about that. Is the product I worked currently. Let's go and check. Sorry. Okay. First of all, what is doing here, the animation is composing a user interface. After composing visually a user interface, there is some delay with the screen. I'm sorry. I'm going to try to, okay, to play again. So the first thing you do is, okay. I think there is a delay with sorry. Let's try again. It's blocking, but okay. On the right, you have styles and the object. You can compose a user interface, dragging components and widgets. So what is going, let me try to block it for a moment. I can send you the link with the video. It's probably in Zoom is not working. So first thing you do is you select graphical components to create the user interface. After that, visually, let's see. Can I go step by step? Let's try this way if it works. Sorry for the confusion here. Okay, what you can see here that the developer is composing the user interface, dragging and dropping graphical components. It's clear these graphical components are linked with the data that they should be displayed. And you can create to say if what we call a maquette or a mock-up that is a visual representation how this interface is going to be displayed. So you have different widgets. The other components that typically you have in this and is the representation of the data layer. So all the data, the database, all the data that should be represented on the application. In this case, is a product, a part, and you have a relationship. These are, at the end, are objects that the code can store and retrieve through queries, but you don't have to write code. The only things that you write is the name of the attributes and the type of content. There are a lot of other stuff related to security, to roles, to users, but everything is done dragging and dropping components and filling typically text in drop down. So you can, oh, sorry, it's complicated. I have to center my cooker. Okay. We have to ask Zoom to improve something here because my cursor is not stable. Okay, after that, it came the so this is quite a disaster. Let's see if we can do something. Okay, so how you code? So we see the user interface. So no need for JavaScript, for HTML. We saw how we organize the data. No need to know how to implement SQL queries. almost at the first level. This is the reason I call low code, because there are cases on which you still have to write some code. So the logic is created putting together these bricks. Each bricks implement some kind of operation. There are a lot of different operations, from string operation, mathematical operation, database operation, but everything is done visually until creating. I want to get out from this slide as soon as possible. You just click on the deployment button, and what you get is the deployment of, in this case, a mobile application in the cloud without almost writing a line of code. And this is not just a game or a playing. These are tools that allow us to develop application at very high level, enterprise level application. So sorry again for the problem with the video. There are a lot of low code and no code platforms, some more expensive, some less expensive. To give you an idea, I'm working implementing this kind of platform for one of the largest car manufacturer in the world. So we are not talking about small, low level and silly application. We are talking about serious stuff. But the good thing is that if you want to start to do something simple for yourself, is an extremely easy way to start to familiarize with application development. There are these if used for professional goals, these platforms are quite expensive, but some of them allow us to play with them, to do proof of concept free. And there are also, if you search on the net, free open source ones. So a market that is increasing extremely fast. And one of the promises of the low code, no code movement is bringing what is called citizen developers to develop. Is not that everyone can start developing an application, but if you have some kind of technical, or you invest, sometimes you can participate to the process. Almost this is my vision. You always need at the end a software developer, a software architect to engineering that. But in my experience, for example, we are building applications that start from technical workers and the engineers in production, for example, that they have idea, they start to do a prototype, the business analyst, the business professional can interact, because you can see, I don't like the interface like that. I'd like to dropping another component, say I prefer in this way. I don't want adding an attribute to the entity relationship, to the database. This can be done in participating all together. And this is something that is extremely important. Why? Let's jump a little bit further, because the software development is not so funny sometimes. This is my experience of what I like and what I not dislike. Is interesting, but it's not all good time. Like when you write code for your hobbies or for your robots or so on. So the peak of the entertainment on the software development for me is defining new algorithms that no one thought about and code them, or library coding. So the most flexible and interesting code that everyone is going to use. But the whole life of software engineering is debugging, understanding user requirements, and sometimes it's almost impossible because they are contradictory. Spending a lot of time in what is called continuous integration, continuous deployment. Integrating cloud services, and we will talk about a little bit. See the hours, okay. Trying to understand the other developers' code. This is one of the most difficult things, because if you start to have 400, 600, 1,000 line of code written from someone else, you have to reverse engineering. There is no way to read the code like a text. You have to start to look at piece by piece. And sometimes the code written by other people is not so good. Sometimes it's incredibly complicated to put together. I spent some time in my career doing reverse engineering of code to understand what some old software was doing, because everyone lost the documentation is never enough to understand, or the people was changed company. So reverse engineering could be interesting sometimes, but believe me, it's a long time, long hours. Struggling with security requirements. Security is becoming always more and more important, and this becoming, I don't want to say that 50% of the time that you have to spend on building something, but perhaps sometimes it's also more. There are a lot of requirements, and you have to be sure that your software is not going to be hacked. Copying code, the snippets from Stack Overflow and GitHub, but you perhaps are very young, but a lot of time developers spend time browsing the internet, finding some piece of code that they can copy and paste. And this is the majority of code is done this way, believe me. Refactoring boilerplate. What does it mean? Boilerplate is all the software that doesn't really, is all repetitive, like user management, tools for data migration, and a lot of stuff that is always the same, but it's a little bit different. So you have to take these libraries and readapt them. And debugging, hours on debugging, and arguing with quality assurance and the architects. Believe me, it's not easy sometimes. I was more on the architect side, and developers are never happy with your design. So why I'm saying that? Because low code, no code, what is targeting? It's targeting the submerged part of the iceberg. So if you can do something there, you can still do some precious code and libraries, but you can wrap these in your visual representation and allows others to move the blocks. All the rest, not perfectly, because these are platforms that are evolving, but all the rest, we are trying to make it automatic or almost less tough in terms of time. This has a consequence that we'll see at the end. Why I'm talking also about cloud computing. I don't know if you're familiar. I can't have a feedback, but let's say the cloud computing is someone else is managing all the hardware. This is how to start. So instead of having the hardware in my office at home, there is a powerful network. I move all the hardware in a data center somewhere. And this is how it started. After that, they start to say, you know what, I'm not just giving you the hardware, I'm virtualizing. You don't know which hardware you have. You don't have to think about how powerful must be. I can improve the power of your hardware of your resources without you knowing. And this is this elastic scaling infrastructure. And after the infrastructure, it came the software as a service. This means I'm not only giving you a machine or a virtual machine, a network where you run your software. I'm giving you the software. Like software that is provided not as something to install, but as a service. So there are interfaces that are called APIs, the application interface that allows the exchange of information, programmatic interface. And I instruct you how to interact. So if you want to do, for example, have a database, I'll give you a database. If you want, I don't want to enter in detail. If you want to say a tool to analyze data, I'm going to give you the tool. If you want text to speech, if you want speech recognition, if you want image recognition, I'll give you all this stuff to you. And this is a case of AWS, so Amazon Web Service. There are other clouds. The most Amazon is probably the biggest. There is Azure from Microsoft. There is Google Cloud from Google, Oracle Cloud. There are a lot of providers. As I said before, I'm showing you what I know better. So this is a small sample of all the software as a service and platform as a service, infrastructure as a service bricks that you can use to compose your application, your system. Because at this point, it's not your solution, as we say, but it's more a complex system. And how does it happen? Look, typically on the left, what you see is a typical cloud architecture. So you start to design putting all these bricks on your chart. There are hundreds of these symbols for each cloud, and you define a complex system that has different elements: hardware, database, API gateway for the API firewalls, systems for cryptography, different kind of flavor of open source. And till now, this composition, this is a simple one. I didn't want to put a more complex. What this means is that someone have to code this, and this is other code that is called, let's say, infrastructure scripts that run, telling to the cloud that is not in your computer how to connect all this stuff, which kind of data, all the roles, the security. We are talking about different things. We are not talking about the low code platform for now. In the next slide we put it both together and we will understand. But surprise, surprise, what is happening in the cloud world is that instead of using this coding of the infrastructure, so it's software infrastructure as a code, network as a software, there are different, because you're coding instruction to connect all these elements that are more virtual than real at this point. What they are doing is say, you know what, it's too complicated. There are these Terraform script that are, Terraform is a tool that allows to create the infrastructure. We give you, surprise, surprise, a visual interface where you can pass and drops element, connect them, and this is the same things we saw before. The history is from complexity to text to coding to manipulating images and metaphors. So there is a continuous approach to abstraction, I would say. So everything became more abstract. It became a symbol. It's not more something that you see. I started my career mounting servers on rack physically, connecting them. And now what I do to have my infrastructure is moving boxes in a screen. This is quite revolutionary, because if we put together low-code and service integration, we have something that is, let's say, is a perfect marriage, because you can use the cloud infrastructure to do extremely complicated things. So imagine how complex could be coding a system for visual recognition of, I don't know, for example, I worked recently on an application for, I didn't develop it, but for insurance that recognize damage on the car. So you take a snapshot and describe and try to understand if the car has been damaged and how it's been damaged. Coding this can require time, but not also for the algorithm. It's buying the hardware to do that, implement the software for image recognition, training the model, and so on. For example, I have a small GPU to implement the software visual recognition, but it's to do the simplest things, it takes hours, and this must scale to something extremely powerful. And June knows something about that, because we were working together in recognizing license plates. So at this point, you have this power, but how I manage this power at this point? So how I interact with this project, because the service is there, but yeah, there is an API, an interface, data going, data coming. You can use low code to create the human machine interaction and all the logic, the small logic that allows you to put together all the service. So, and this is something that was not discovered, was not really understood, but now there are a lot of partnership between low-code providers, the same Microsoft has almost everything, and cloud computing. So let's try to go very quickly. One of the things that low-code is doing very well in this moment, perhaps you're interested in that, is IoT, so Internet of Things, connecting device sensors, actuators, and summarize and massage the information and present it, or giving the interface that are easy to interact with. And this is implemented at industrial scale. So it can be very quick. It is interesting to create very quickly mobile application to collect data from sensor, from actuators, and so on. I want to leave some time for the questions, so I'm going fast. So now let's talk about something sad. So we see all this stuff, but these guys of the low-code platform are starting to introduce artificial intelligence. We have to discover what this means. So what this means that we are going to have, oh, sorry for the mistake, software that writes software. It's not just a software generator. So I write put some boxes, and each of these boxes with some parameter is producing generating Java code, for example. We are talking about software that is capable to write software. Try GPT. It's struggling a little bit, but if you ask to write an algorithm in C that do something like calculating the first 1,000 prime numbers, it's going to do it. And it's also saying, please write me describe me a microflow of low code to do the same is going to do that. And this is what I call a strange loop, because it's something that is designing itself. I put here one of my favorite books, you guys, if you want. This is a very old book. But if you like software, if you like artificial intelligence, if you are like logic, art, and music, is an incredible book. And the author is this book is what came out with this strange loop ideas that is around intelligence. So this is interesting because if you ask me, so in 20 years, will machine write software and software developers, engineer will be unuseful? I don't think so, but there is a catch. I will impact software engineering. It will do. And where it will do. Do you remember the iceberg? All the lower part. That is likely going to be automatized. Not completely, but a lot. Look at what happened in whatever factory in the world. So if you ask me when, I don't know. We can talk about the artificial intelligence for long terms, but I think that in software, there are three roles. There is the people with know-how, the know-how to put together all the mystery of the variable, the scripts, when you put together something, it's not working, so you have to find the guys that do it before, and you spend a lot of time on calls on Teams or in whatever platform, trying to find someone that did it once, but there is no law, there is not, how to say, nothing. So you have to know how the things put together, but there is nothing that is not just knowledge of how it works. And this is well protected, because if you lose this information, you lose the, how to say, your value. The other part is to know why things happen. This is general, not only in the software industry. So this is more on why I'm doing that, because a lot of software development is having a flow chart with from the business analyst with the description. You just have to translate it in code. And this is, you know how to translate in code. Knowing why is I'm able to define and to describe and to create. Creation is not the word I'm searching for. You know why things happen, and you can design them. And on the top of, there is a solution creation. Is the least probable things that low code, cloud, and artificial intelligence will be never able to do. So guys, invest, from my perspective, invest in first principle thinking. Be able to go back to the root and be creative. And this will allow you to adapt and is not surprised to whatever is going to happen. So yeah, almost was able to remain in time. I'm here to get, if there are questions.
So if there are questions, you could either type them in chat, or you could unmute your mic and say the question.
Let me recover Zoom here. Okay, where is the chat in Zoom? Here. Okay, it seems there is nothing. So okay.
So one of the
Can you
questions
give me feedback, because I don't see anything in the chat here.
okay, one person says, could you comment a little on quantum computing?
Oh, so quantum computing is is something that is going around from a lot of time. If you want to play with quantum computing, there is a lot of possibilities on Google, on IBM, that you can do for free. We can talk about the quantum supremacy on doing a lot of strange stuff, but there is also a lot of misunderstanding about what a quantum computer could do, and not only from what is capable to do in algorithmic terms, but what is the level of coding on a quantum computer. So we are at the level in quantum computing where you still are lower the machine language. So you have to design your own gates to do something. There are gates, composition of gates. Gates are this part, logical as a quantum state can be. It's perhaps the less logical stuff that is around. But you have to put together and build your computer, and it's very complicated. There is no simple way to do that now. So it can be very good decrypting for security, but I don't see in the short term a lot of application. I could be wrong. I studied a couple of years studying about quantum computing. I don't think that for now there is a real market, but this is my opinion. Can be wrong. This doesn't mean that it's not interesting to study. But if you want to start to study quantum computing, I can recommend you start from here. I can focus. I can give you the books, but this requires a lot of calculus before starting to study. So, and this is the Bible of quantum computing. You can focus. It's not good. It's okay. But okay, I'll send you the link. But so you can play with it. You have to compose gates. If you want, we can try one afternoon. If you want, we can try to put something together. But it's early. Invest. If you want to invest in studying quantum mechanics, is one of the most interesting stuff to study. I studied mainly for laser application, but at the end, I like a lot of people, I gain my bread with software. Okay, there is another question. Oh, why creativity is important? Because what is not creative can be done from a machine. So what means creativity in software? It's not only about writing algorithm, it's also be creative in solving problem, optimizing solution. There is a component of art in designing software solution, and sometimes it's also difficult to manage. You have to be creative in managing teams, but I think that what is now the value of a lot of software developers is, I said before, knowing how put together stuff that and make it work together. But there is not a lot of value on, for example, defining new way to implement the system. Or don't misunderstand me. This doesn't mean that people that is working now in software development is not clever, or I know people that is capable to optimize the systems in an extremely creative way, making more fast. But we also have to take in account that a lot of people that was working in jobs that doesn't exist anymore were extremely creative. So a steam locomotive designer had to be creative and had to understand the principle, so go back to the base to become something different. So watch out, software is a great industry. It will be a great industry for other 10 years, I don't know. But this doesn't mean that will be always the same from a career perspective. So take your eyes open, study a lot, be curious, and be creative.
There are actually two questions above that. One of them being, do you think AI can completely replace CS?
Whom? As replace what? Sorry.
One of the questions above the one that you answered was, do you think that artificial intelligence can completely replace CS?
CS stand for, sorry?
Computer science.
Ah, okay, sorry. I never, okay. I don't think so. So someone have to write the artificial intelligence systems. His problem is not, his problem is how change the kind of job that they're doing. So if you see now all the young guys are investing on artificial intelligence. That it doesn't, at the end is building software systems that implement tensor mathematics on large scale. It's different from what I was taught at the beginning. So logic boards, algorithm, and so on. So there is not an algorithm in deep learning, but there is a level of an upper level of abstraction. So the people that was working there. So this doesn't mean that everyone have to work in artificial intelligence, but there is a risk. I'm quite sure that a lot of the simplest stuff is going to be quickly implemented that way. It's going to be slow, perhaps slower than the new. You know, there is a lot of hype now with the ChatGPT. Everything seems it's incredible. But if you push ChatGPT at the limit, it's not going very far. This doesn't mean that it is not going to increase. If you, so there is people much more successful than me in engineering that is saying around that artificial intelligence is one of the biggest risks for humanity. I'm not so pessimist, but like very powerful tools, came with very powerful tool, came a very big change in lifestyle, and a powerful tool can be used in the wrong way. You don't. I think you can understand how. This is, but here we are going more in the social science and perhaps also political science than engineering. Other questions? I try to be in time, I think, but I have some time if you want. Okay. Look, for example, I wanted to use ChatGPT and Open AI to do this presentation. It was, I think that all the text, if I didn't tell you at the beginning, you could imagine that was done by person. That is not very good doing presentation, because this is not, I tried to say I want smaller points for a presentation, but is a text processor, is tend to be very prolific in how it's script, but everything makes sense. But everything is an average. It's like an average idea. There is not a lot of creativity. So the creativity is doing the question that was important. On the image side, I try, for example, this should be a computer with a smiling face from Leonardo da Vinci. I think we are not there. But it's a fuzzy representation of the reality. Let's say this should be Michelangelo. That makes some sense, you know, the famous painting of the Sistina Chapel. This should be Mondrian, that is doing something with a robot, but it's not clear what it should be. Let's say, for example, this should be Van Gogh. Just to cite but it's interesting. You can do that. I didn't want to show you how to generate code. You can go to ChatGPT and say, write me. So doing this live, I could ask, what are the languages that you know? We can do live. If you in the future you are interested, till June, and we will find some other time. I really like to help and to participate. I'm suffering a little bit of the interaction with the video, but other sign of the time. Okay.
Thank you, Alessandro. I think Dave still have more questions to ask you. Do you still have more time?
I have some time, yeah.
Okay, thank you.
Okay, so another question is, what do you think of ChatGPT? It's being used to write recommendation letters using AI, and even at like robotics regional competitions, judges are going to implement AI with judging. So how can or will AI replace human beings, and
okay,
what can there be?
ChatGPT is so to understand ChatGPT, you have to go back on how it's been trained. So they inject compress in a compressed way a big quantity of data, and the intelligence that would respond, there is some creativity, but this creativity comes from scrambling and reordering concepts that are common. So I don't find creativity is how to say, crunching stuff that is already there. Is mixing stuff, and mixing stuff seems creative sometimes. So ChatGPT is not going to pass the Turing test. Do you know what is the Turing test? Okay, it can take some time, but look, so Turing was this incredible, is the father of the modern IT, computer science, and he was thinking to this text. So you have a room, okay, where you put some questions and you get an answer. The moment you are not able to understand if on the other side there is a human or there is an artificial machine, this could pass the Turing test, and GPT can't. You at the end. So if it's something like write me an essay or recommendation letter, it's just taking the best of what is around. But if you push to the limit, is you can understand. Sometimes it's repetitive. It's saying it always the same time. It's improving. So it's a text. At the end, is a text process. Also, the code came from the training data that has been put inside. It's going to change something, yes, especially for if we. So I don't want to ask you if you use ChatGPT to write some school tests. The teachers say that they have a method to understand if it's been written by ChatGPT. I don't know, could be. I use it, not in this case. For example, if you have an email that you want to embellish, to rephrase, it works perfectly. You have never sent it before reading, but it works well. I tried here to use it to write a presentation, but doesn't seem to perhaps the way I'm asking. Yes. What is interesting, very interesting, is the image processing, especially from a robotic point of view. So I don't know how this. The last time I saw this robot wars was with remote controls. I hope there will be battles of autonomous systems. At this point, you have to manage vision, you have to make tactical strategic decision and so on. I don't know if I don't want to believe it, but I don't think that we are going to see self-conscious machine. There is too much in the brain. But there is a British scientist, Sir Roger Penrose, a Nobel laureate, that at the end, instead of, it was the Stephen Hawking's teacher. And he started to write stuff about self-consciousness, saying that it's not just neurons, but there is some quantum effect in microtubules and stuff that I didn't study, but it could be interesting. So there is people that believe that it's something more than just a neuronal network. And the software neural network are still extremely complicated are a simulation of a chemical machine, electrical, chemical, analogical. So they require a lot of power. This is my opinion, but I was wrong a lot of times. Sometimes stuff never came, and sometimes stuff came before I was expecting. Does this respond to the question?
I'd say so. Our next question is 10 years from now, the kids here in this meeting will graduate from college. And what are your recommendations for them to prepare for the new AI era?
Good. Look, recommendation. You should ask someone. So I have experience. I don't know if I can give you advices, because independently from this kind of choice, there are a lot of things. Depends on what you want in life. If you want to be rich, there are different ways. If you want to spend a life learning and never be annoyed of your job, and study a lot of physics, a lot of mathematics, because it's what you give you the base to understand everything. I think I'm talking to the right guys, but because you're all interested on STEM, so, but never forget the basics, and be able to go back to the first principles. And okay, I was saying this before Elon Musk was saying that, but I never wrote it. You can't rethink and think differently if you are able to go back to reverse engineering the entire case, understand why this is happening. So there is a lot of stuff that doesn't make sense here, and let's do that in different ways. And other things, invest in your social skills. Is extremely important. And for example, this is something that I never invest too much, but during study, the university time, but starting to work in the industry is extremely interesting. It's extremely important to be capable to communicate properly. Things that I still didn't learn totally. Let's say that is language problem sometimes, but you know, how to present, how to communicate. If you can't communicate your ideas, then you typically have 30 seconds to transmit it to the people that can help you. And know yourself. This is also important. There are a lot of, I think that the psychology of the big five characteristics of your psychology has done very incredible advances, and you can self-assess you and say, okay, for example, I'm low in consciousness, I'm very high in openness, I'm very creative, but I don't like it. I'm not able to focus or to do stuff that is repetitive. So when you know yourself, you can compensate. There are two ways to compensate. One is changing yourself. Second is working with people that is different from you. And this is extremely rich. So this is my experience, but more from my error, from my mistakes, than from my success. Other question?
Yes, our next question is, what got you interested in software in the first place? And what did you think the future of computer science would look like when you started studying software?
Look, first of all, software for me was a hobby. At the university, I took 2 classes of computer science. I studied a lot of physics, a lot of calculus, but so when I'm quite old to remember that computers were something that you had to access with people in a white no, I think it's called scrubs and big disk tapes. So something that was incredibly fascinating. So I started studying Fortran. I don't know if you know that there is a language that is called FORTRAN, formula translation. After that, Pascal, but what I started to do, meanwhile, I was studying, like all the engineering students had my home computer, the Commodore 64 at the time. And I started creating software for my other studies, for example, a bow diagram software to calculate the stability of systems, or strange stuff, or playing with video games. Now, what brings me to software is that I started working on a very low-level software because this was a company that was very close to my house, and it was a research lab. I was working on speech recognition, and was not current with my study, but I was extremely fascinated by, especially 30 years ago, speech recognition was something extremely basic. So I started developing digital filters, real-time digital filters. And from that, I started to write some other code in C, no C++, in C. With very complicated development system directly for microprocessor. At this point, I started to work more as an architect in a telecommunication company, and I tried a lot of different stuff in my life. And now I'm back to software, but having, let's say, this more general, not specializing myself till the end, also allowed me to find something new and to reuse the experience in different fields. So software, because I love computers. And I think I don't know how to explain. Is that part of what I like. And but I work more on the software architecture, algorithm design, stuff like that. But I also spend a lot of time managing teams. Also, arrive to have very large teams, and yes, I enjoy it. But at the end, what I like more is designing. So follow your instinct. Software development future is uncertain, as everything. I don't have answer. It's going to be interesting because we are in front of a new revolution. There is my belief is something is going to deeply change in the way we develop software. It's going to be more abstract and more high level. It's a constant in everything evolved in the technological realm. Okay.
Okay.
Guys, other questions?
Yes, our final question is, how does AI work together?
Work together with what, sorry?
Probably means how does AI work with the information that it has?
Okay, I'll try to answer. What? So there are different. So you should read the story of artificial intelligence. It started with trying to define the logic of reasoning. So a very logical level. There were languages that were specifically designed to be very close with formal logic. So the first idea was that with logic, that intelligence was something, let's say, algorithmical. And this went for 30 years, 40 years, but no big results. So what came all together with it started with deep learning. So I worked with simple character recognition based on neural network perceptor that was based in, I don't want to, let's say that 1990, and the Alcatel Research Laboratory was quite a disaster. But so this AI stuff is not new. Why this is now is working? I'm going to say something strange, okay? Implementing a neural network, apart all the theory that is evolving, there are this simulation of, let's call them simple neurons with simple connection. They are not going to have thousands of connections. Define the typical layer. We can. It's too long to talk about that. But I think about the. It's not physical. There is someone that tried. There is an Italian researcher that is cultivating neurons to drive robots. Real neurons, not a fake one. So artificial intelligence now is a simulation of this computer network. So there is not algorithm there. Theoretically, you don't know what is happening inside. So you know that you can extrapolate something. For example, I have this computer vision work extracting shape, but there is no one that is programming. A robot is someone with 2 eyes, or a person is something with 2 ears, one nose, put in this. No, you just feed these networks with the training data and say, if these are the inputs, this should be the output. Let's say I'm simplifying. So why now? Because of video games. And not because the software of the video games, because of the graphic card. In fact, one of the biggest provider of hardware for artificial intelligence is NVIDIA. You know, I suppose if some of you is a gamer. So why this? Because these machines are that were born to manage geometry, vectors. It happened they were perfect to implement these neuron models. So now this is a market apart, but I don't know if I can show you. I have to open the computer. There are what are called tensor. They use tensor mathematics. That's an evolution, super class of the vectorial mathematics, and they are capable of crunch incredible quantity of simple operation. And this is strange. So now the problem with, for example, ChatGPT, that the cost of one transaction is extremely high in terms of energy. These are very expensive. So they still. I don't remember how much, but it's a matter of some cents for each query, and I don't want to be wrong. So this is the reason artificial intelligence came together, but is deep learning. I still don't like calling artificial intelligence, but it's also debatable. I prefer to call it deep learning or machine learning. Depends on what you define something to be intelligent. One definition is intelligence is everything a machine is not capable to do. So as the machine can do something more, the intelligence is above. It's not, someone doesn't like this definition. Guys, unfortunately, I have to go. I'll send to, if you want to do something else or talking about quantum computer, I need some time to prepare it. but I'm here. I love to talk to young teams, especially, and let me know. I can put in the chat my email if you want to. Just a moment. Oh, I lost my cursor. Okay. I have a message here, but it's not working.
Alexandra, I can share your email.
Share my email, yeah, because next time, please, let's use Slack or Teams. My Zoom is not working.
Thank you very much. Yeah.
Thank you, guys. It's
Thank
been
you
a
very
pleasure.
much.
And sorry for the incident with this, the video that was not working. I tested, but it's not working with Zoom. But
thank you very much.
Okay.
Bye bye.
I guess that shall conclude today's STEM forum. Thank you again very much, Mr. Stagni, for presenting. I hope everyone has a good evening.
Thank you.
Thank you. Bye.
Bye.
Thank you. Bye-bye.
Thank you.
Thank you.